Alrighty, so let's finish example 4, part B and C. So as a reminder, example 4, the directions are, so we're given a function that has at least one rational zero. We're going to use this fact to find all zeros of the function. If there's more than one zero, we're going to separate them with commas. So for part B, we're given g of x equals 9x cubed minus 21x squared plus 4x plus 4. So as I can see, the leading term is 9x cubed. So this is a third degree polynomial. Since it is a third degree, first what I want to do is I kind of want to mentally check here to see if I can even factor this by grouping. So I noticed 3x cubed and 21x squared, they both have a 3x squared in common. Then I'm left with 3x minus 7. And then over here, they both have 4's in common, and I get x plus 1. Right, as you can see, these are not common binomials, so this method does not work. However, because we're told that we have at least one rational zero, we know that we can use the rational zero theorem. So A naught, remember it is the constant, it's the number without the x, so it's 4. And my factors for that are plus or minus 1, plus or minus 2, plus or minus 4. Okay, and then a sub n, so our n is 3, so our a sub 3 is 9, and then I can write that as plus or minus 1, plus or minus 3, plus or minus 9. Okay, so P, the possible rational zeros, okay, it is a naught over a3. When I do that, I get plus or minus 1 over 1, plus or minus 1 over 3, plus or minus 1 over 9. And then I have plus or minus 2 over 1, plus or minus 2 over 3, plus or minus 2 over 9, and then plus or minus 4 over 1. Fix that real fast. Plus or minus 4 over 1, plus or minus 4 over 3, plus or minus 4 over 9. Okay, so I have plus or minus 1, plus or minus 1/3, plus or minus 1/9, plus or minus 2, plus or minus 2/3, plus or minus 9, 4. So I don't need to include that because I already put 1, plus or minus 4/3, and then plus or minus 4/9, plus or minus 4/9. Okay, so we have a lot of rational zeros to choose from. Okay, so let's get started. 1 is usually a good place to start. So I have 9, negative 21, 4, and 4. Okay, when I do that, this is 9, negative 13, negative 13. This is negative 9, negative 9, negative 5. Okay, it's not 0, so this is not an option. Okay, then we can check negative 1, so 9, negative 21, 4, and 4. Okay, this is going to be 9, negative 30, 30, this is 34, negative 34, and then negative 30. Okay, again, negative 1 is not a 0. Okay. So let's try another one. I'm going to try 1/3. So 9, negative 21, 4, and 4. I just want to let you guys know, you don't necessarily have to go in order. You could do plus or minus 1, then plus or minus 2. Yeah. So not necessarily. I like to go in order just because it's easier to keep track of. But it's up to you. So here's 9. This is going to be 3. So this is negative 18. Then this is negative 6. Then negative 2. Negative 2/3. Okay, so this would be 12/3, so this is going to be 10/3. So not 0. Okay, I do suggest though that if you pick 1, I would do the negative because you never know. And just so like, yeah, so it'll be easier to, so once you're done with that, like, okay, I tried this one, and then do the 1/3. And if that doesn't work, then you can just cross off both. Okay. So I have 9, and then this can be -3, then this is -24, -8. Oh, sorry, +8. Okay, and this is -4. We get 0. I'm going to put a smiley face because this means that -1/3 is a 0 to g of x. Oops. Add some space here. Okay, so now we can consider 9, -24, and 12. So again, normally when you get to the quadratic, so when you're left with 3 terms, we normally start factoring, like use what we know, but you could still use this to keep on going. It is up to you. All right, but I'm going to factor. So normally what I do is I put g of x is equal to, and then I put the terms. Technically, you don't have to do that. You can just say, like, observe 9x² minus 24x plus 12. Like, you can just do that right away. I just wanted to show you guys what we have so far. Like, by synthetic division, this is what I get. Okay? But let's just do it this way to show you guys another way. So I'm going to divide everything by 3. Another way to think about it is I'm going to factor out a 3, and I'm left with 3x² minus 8x plus 4 is equal to 0. Then divide 3 from both sides, and I have 3x² minus 8x plus 4 is equal to 0. Okay. So now we're going to ask, what are 2 numbers that multiply to be 12 and add to be a -8? All right, and then that is -2 and -6. Right. So 3x² and then so minus 6x minus 2x. Okay, you could also done minus 2x minus 6x. Doesn't matter. Okay, and so this, they both have a 3x in common. Then this is x minus 2. Okay, and this is minus 2x minus 2. Okay. If you didn't want to do that, so again, I think this is quicker if we do it this way, like to find that. You can also do like the guess and check. But you could always use the quadratic formula, or you could complete the square. But luckily we can factor by grouping with this one. They both have an x minus 2 in common, so I'm going to factor that out. And when I factor that out, I get 3x minus 2. Okay, so by the zero product property, I can have x minus 2 is equal to 0, or 3x minus 2 is equal to 0. Oops. So by zero product property. Okay, so then I'm left with x is equal to 2, or x is equal to 2/3. Okay, so what are my zeros? My zeros, so we have 2, 2/3, and then don't forget the one above, we have -1/3. One way to check, so, because I know this is quite a bit of a process, just keep in mind, because this is a 3rd degree polynomial, we need 3 zeros. Okay, at least 3 zeros with multiplicity 1, but at least when you count all the multiplicities, they should equal our n, which is 3. Okay, so yeah, if you did only like 2 2/3, then you should say, what's my 3rd zero? And then you look up, and then you'll see that you circled this, so you don't forget. Okay, and I forgot to put x. Okay, so but these are our zeros. All right. So now, and again, so like if you wanted to, instead of doing fractions, if you didn't want to deal with fractions, you could have tested positive 2, okay, and 2 would have been a 0, and then you could have, then you would have found 2/3 and negative 1/3 by factoring. All right. So, but lastly, let's do part C. So part C, we are given h of x is equal to 7x to the 4th plus 20x cubed plus 12x squared plus x plus 2. So it's really nice with these examples that they've all been decreasing and we have no placeholders. Okay. So because it's a 4th degree, our best bet is just immediately using the rational zero theorem. So what is my A naught? My A naught in this case is 2, and my factors are plus or minus 1, plus or minus 2. For A sub n, our leading term is 7x to the 4th, so this is a 4th degree polynomial, and our A sub 4 is equal to 7. So this is plus or minus 1, plus or minus 7. Right? And then so our possible rational zeros, okay, so is A naught over A4, and they are plus or minus 1 over 1, plus or minus 1 over 7, plus or minus 2 over 1, plus or minus 2 over 7. So if I simplify this, this should be plus or minus 1, plus or minus 1/7, plus or minus 2, plus or minus 2/7. Okay. This one's a little nicer than B just because B had so many possible zeros. Over here, we just have 8 options. Okay. So let's start with 1. That's usually a good place to start. And then my coefficients are 7, 20, 12, 1, and 2. This is a 4th degree polynomial, so I'm supposed to have 5 terms. I see I have 5 numbers, so this is good. Okay, so bring this down. 1 times 7 is 7. When you add, you get 27. This is 27, 39, 39, 40, 40, 42. Okay, so not a 0. Let's try negative 1. Just a reminder, if you don't like synthetic division, you could still use long division. So you could have done, so if we know that these are possible rational zeros, so this negative 1, remember that's our C. So x minus c would have been x plus 1, so it would look like this. And then your 7x to the 4th plus 20x cubed plus 12x squared plus x plus 2. Okay, you could do it that way as well. But I like synthetic division because I think it is a lot faster. Maybe for the next one I will show you, but because I already have this set up, I'll go ahead and do it. So 7, negative 7, 13, negative 13, negative 1, 1, 2, negative 2. Okay. So this tells me that negative 1 is a 0. Okay, so one of our good cases. Right, but so this is going to be a 3rd degree polynomial, and when I look at it, you'll get, so this is 7x cubed plus 13x squared minus x plus 2. Okay, when you look at it, you cannot factor it by grouping. Okay, so we got to keep going. Again, so you have 7, 13, negative 1, 2. It is always nice to check the negative 1 again in case there is another multiplicity. So in case negative 1 has a multiplicity of 2 or more. Okay, so this is negative 7, 6, negative 6, negative 7, 7, and 9. Okay, so no, this just means that negative 1 has multiplicity 1, not 2. All right, so let's move on. So we could try fractions, but I'm going to do 2. Okay. So I have 7, 13, negative 1, 2. So this is 7, 14, 27, 54, 53, 106, 108. Okay, so 2 is not a 0. Okay, let's try negative 2. 7, 13, negative 1, 2. Okay, so this is 7, negative 14, negative 1, 2, 1, negative 2, 0. Okay, I'm going to put a smiley face because we found another 0. Right? So we found 2 zeros, and now we've reduced it to a quadratic. So now what we can do is we can continue going. You could try it out. So because we're more limited, so again, we don't have to check plus or minus 1 again, and we also don't have to check plus 2. I would still check minus 2 with the new one in case it's a multiplicity. But when it gets this small, when it gets this small, like as you can see, like this a naught and this a sub n, it's plus or minus 1, and then you would have plus or minus 1, plus or minus 7. Okay, so what does that tell us? That tells us technically we don't need to check the negative 2 because that is not a possible rational 0 for this particular quadratic. So it just means negative 2 is a 0 of multiplicity 1 for h of x. And technically all you have to do is check this plus or minus 1/7. You don't have to check the 2/7. Okay, so don't always have to redo the zeros, but sometimes it's nice because it reduces what you have to look for, right? But we're going to keep going. So I'm going to observe my 7x squared minus x plus 1 is equal to 0, right? Are there two numbers that multiply to be 7, add to be negative 1? Unfortunately not. So we can either solve it by using the quadratic formula or by completing the square. Again, I will complete the square. Okay, so at first, doesn't really matter with the order you do it. I'm going to do this first. I'm just going to subtract the 1 over. Okay, and then I'm going to divide everything by 7 because remember we need our leading coefficient to be 1. So this is x squared minus 1/7 x is equal to negative 1/7. Okay, so we have x squared minus 1/7 x, right, plus, and then this is going to be this is going to be negative 1/7 times 1/2, quantity squared, is equal to negative 1/7, and again, we're going to add, because we want to add it to both sides to keep this balanced. Okay, we can go ahead and factor this. This is x minus, and then we have negative, so this is negative 1/14. Okay, and if you FOIL that back out, you should get negative 1/7, or you should get this. Okay, and then so this is negative 1/7, and then since we know, so this is negative 1/14, but negative 1/14 quantity squared, that is plus 1 over, and then 14 squared, I think, is 196. Let me check real fast. Yeah, 196. Okay, and then gotta keep going. We want to combine the negative 1/7 and 196. So, okay, 1 second. So that's 28. So this is going to be negative 28 over 196 plus 1 over 196. So then we get x minus 14. Oh, geez, okay. Let me make this more clean. And this is negative 27 over 196. So this is x minus 1/14 equals plus or minus the square root of negative 27 over 196 by the square root property. solving for x, I get x is equal to 1/14 plus or minus, right? And then, so the square root of negative 27 over 96, this is plus or minus this I square root of 27, and then we know that this over 196, the square root of 196. If I simplify, okay, I'm not even going to put arrows, because this is equal to this, x still equals this. Okay, 27, there's a 9, so just to show you what I'm doing, the square root of 27, this is equal to the square root, and then this is, 27th is 3 cubed. Okay, another way to think about it is 3 squared times 3. So this is 3√3. Okay, so 3I root 3, and then we know from above 196 is 14 squared. Okay, so the square root of 196 is 14. Right? So you can leave it like this if you want it in the a plus bi form. Okay, well technically, okay, if it's a plus bi, it should be 1/14 plus or minus 3√3 over 14i. Okay, that's the proper form. But because if you want to keep it as 1, it can also be 1 plus or minus 3i root 3 over 14. Okay, I guess it depends how they want you to format it. Yeah. Okay, so what are my zeros? Okay, my zeros, so I have 1 plus or minus 3i root 3 over 4. Okay, but remember, so we have a fourth root. Okay, these are only 2 of our zeros, so we got to find the other 2. So going back, I notice it's going to be -1 and -2. Oops. Okay, these are our zeros. Right. So if I wanted to, just for fun, if I wanted to rewrite h of x as a product of linear factors, then I would have x plus 1, x plus 2, and then this would be x minus, this is 14, minus, and then this would be 1 plus 3i root 3 over 14, and then x minus 1 minus 3i root 3 over 14. Okay, and this would be a product of linear factors. Before, so this example is done, but before we go, I want to just show you guys if you wanted to do this with long division. Okay, I don't suggest it just because it's a little longer, but I just want to show you you can still do it, and it's a good review to see it again. So I'm going to look at -1. Okay, so I have x plus 1. Okay, because remember that's my c, and my factor is written as x minus c. And then we have 7x to the 4th plus 20x cubed plus 12x squared plus x plus 2. Right, so remember when we start the quotient, we just want to look at these two terms. And I'm going to ask how many times does x go into 7x to the 4th? And then my answer would be 7x cubed. So 7x to the 4th divided by x. Okay, this is 7x cubed. Or 4 minus 1. Okay, and then you take this quotient and then you're going to distribute it in your divisor. So then you're left with 7x to the 4th plus 7x cubed. Okay, remember with long division, you subtract. Okay, but I don't like it when we subtract, so I'm going to distribute that negative and I'm going to change the signs. Okay, so we just have to add them. So this is 0. So this is good. So since this is 0, we can move on because that's our goal. Okay, and then this is plus 13x cubed, and then we bring this term down. Okay, now my question is, how many times does x go into 13x cubed? And then that would be 13x squared. And when I do that, I get 13x cubed plus 13x squared. Okay, again, we're going to subtract everything. All right, for those of you that get confused for the sign, just think about it this way. 13x cubed minus 13x cubed, that's 0. I'm going to put a smiley face because we picked the right quotient term. And then this is going to be 12x squared minus 13x squared. So this is just be minus x squared. Okay, it's the same process if you just do this. Okay, because 12 minus 13 is -1. 13 minus 13 is 0. Right, and then before we continue, we're going to bring that x down. Now the question is, how many times does x go into negative x? And that is negative x. So this is negative x squared minus x. When I, oops. Right, and then we're going to subtract the whole thing. Right, so negative x squared minus a negative x squared, so minus, what is, so when you minus, so when you have a negative and you minus a negative, it's going to be negative, and then this is going to become positive. Okay, so this is 0, and then this one, so x minus the negative x is 2x. Okay, this is the reason why I don't like it. To me, it gets a little jumbled, so if we distribute that negative, then we get plus and plus. -1 plus 1 is 0, and then 1 plus 1 is 2. So I think it's a little easier to see. And then let's bring this 2 down. Lastly, we're going to see how many times does x go into 2x, and then the answer is 2. And then you'll get 2x plus 2, and then when you subtract the whole thing, we get 0. Okay, so my h of x, okay, it just tells us x plus 1 is a factor, and then we're left with 7x cubed plus 13x squared minus x plus 2. Right, so, and then going back here, this is 7, 13, -1, and 2. This is written as 7x cubed plus 13x squared minus x plus 2. Right, and as you can see, going from here and here, they're the same. So let me copy it so we can clearly see that they are the same, so you don't have to keep going back and forth. Right, so you get the same thing. This is just, first of all, it's a lot more space, and just, you know, it takes longer to do. Right, but that is it, and I'll see you all on Wednesday.